Bismillahirrahmanirrahim. Previously we talked about the properties of congruent segments, and we added 3 to our list here. This was a table over here on the left side about properties of equality for real numbers, and we went through this in great detail. And then I added 3 here for properties of congruent segments. That is, if a segment is congruent to itself, that was the reflexive property, and if a segment AB was congruent to segment CD, then segment CD was congruent to segment AB. That's the symmetric property of congruent segments. And finally, the transitive property of congruent segments. If segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So those are the 3 properties that we added. Now, these are pretty easy to actually derive from the remaining. So we don't really need to have all of these because they are pretty easy to derive, and you shall see that inshallah today, because I like to give examples of using these properties of congruent segment and proving segment relationships. So inshallah we shall use this to do some proofs today. So here's the first example. This is just from the textbook, one of the examples from the textbook, and let's read the question. It says, given X is the midpoint of segment SY. So here's segment SY over here, and X is the midpoint. Now what does that mean? That means that it divides these segments into 2 congruent segments. Now you have to know the definition of midpoint, and you have to know the definition of midpoint precisely. If somebody asks you what's the definition of a midpoint, you have to say midpoint is a point that divides a segment into 2 congruent segments. So the definition of a midpoint, it's a point that divides a segment, okay, into 2 congruent segments. Point that divides a midpoint, divide, divides a segment into 2 congruent segments. Now that you should know. As I said, geometry is a lot about just basically a little bit of a rote memorization. So what's a midpoint? You have to be able to say it in a more precise way, and then it cuts the thing in half. It's not like that. You have to say a midpoint is a point that divides a segment into 2 congruent segments. So that by definition, but just because it is a midpoint, you know that's what it does. I mean, that's what midpoints do. They divide segments into 2 congruent segments. And then we are also told here Z is the midpoint of YF. Okay, so if Z is the midpoint of YF, that means that's this over here, then these 2 segments are congruent over here. Now we're not told anything else so far. So we're told X is the midpoint, that means it divides this into half, and then we're told that Z is the midpoint of YF. And then we're told one more bit of information, and that's this over here. Now, we're not told that this is not a congruent statement. If you notice, it's an equality statement. However, we know a lot of properties of equalities, don't we? Yes, we do. So here we go. So xy is congruent to xy equals to yz. The length of xy is equal to the length of yz. That's this one is equal to this one. That's pretty useful, right? If they are equal, it means they're congruent. So you can rewrite this statement as xy is congruent, segment xy is congruent to yz, like this, right? They could have said it like that, but they didn't say it like that in the question. I wonder why. Perhaps we'll see why. But anyways, you can rewrite this simply as that, and those 2 are going to be congruent. So that's a very important piece of information, because if those 2 are equal in length, that means basically that this segment is congruent to that segment, right? So that means I could put 2 tick marks over here, right? And if this is congruent, then I can say that's those. You can put another tick mark there because these 2 are equal. So if this one is equal to this one, then these 2 must be equal. Then all 3 of them equal. It means all little baby segments are congruent, aren't they? So that's the information that we're given, right? Now we're asked to prove that ZF, that says that ZF is congruent to SX over here. And that's pretty intuitive once you draw everything on the diagram. So that's the idea. So when you do have a diagram, you want to use it to think through the problem, right? So you can kind of outline the problem in your mind's eye. So what did we do and when we were reading? as I was reading this, if you notice, I put tick marks in the diagram, right? So first I said those two were congruent. As the midpoint gave me that those two is congruent, and then we given the other midpoint, and we got those two small segments to be congruent. That's kind of how our proof will flow, actually. See, and then we were told that those two are x, y, and y, z were congruent, were equal, so we know that those two are congruent, and then but from there we got this. So these two are equal. From there we got them congruent, and then we extrapolate that. That means these two must be congruent. And that's what we're trying. And then from there, we're somehow going to prove that these two are going to be congruent. So that's kind of like where we're going. It's pretty readily apparent visually, but we have to use our properties to prove these. We have to use these to prove where we're trying to go. Okay. All right. So how do we go about doing this? Well, let's start with the proof, shall we? Let's write down our 2-column proof over here. I'm trying to draw the 2-column proof like this, and on this side I write my statements, and here I write my reasons. Alright, that's easy enough. So, and when in doubt, you just start with the given. So I'm going to write the given. X is the midpoint. Hope your handwriting is better than mine. Midpoint of SY, like this, and then you can write the other one too in the same one. Z is the midpoint of YF. Okay, so that's given information. We got that. And from there, well, we can work with this, can't we? So I'm not going to use the second piece of information yet, okay, but I'm cognizant, I'm aware that we have more information given to us. Okay, fine. So I've written this, and for using the first bit of information, I can, X being the midpoint of SY, I can say this, can't I? So I can say SX is congruent to XY. Okay. Now notice what I wrote down is SX is congruent to XY. This is congruent to this, and the reason for that is, of course, from definition of midpoint. Okay. Now, if you recall, this column, the reason column, is going to have given information, it's going to have definition, it's going to have properties, it's going to have postulates, it's going to have theorems. So all the reasons it's given will be one of these categories of statements. Now, what I want to bring to your attention here is we use the definition of midpoint for this, and therefore it's kind of important to know the definition precisely. The point being that I use the definition of midpoint to write that segment SX is congruent to XY. I did not use the definition of midpoint to write that SX equals XY. I did not do that because that's not what the definition of midpoint says. Midpoint, right, it says a midpoint divides a segment into two congruent segments. All right, so this is precision in definition. Okay, so that's why it would be semi-incorrect to write SX equals XY from the definition of midpoint. Okay, nevertheless. So SX is congruent to XY, and then I can use Z being the midpoint of YF, the second statement here, to write that ZF, okay, to write that ZF is congruent to YZ, like this. Now, notice that I wrote ZF, okay, I wrote ZF right here, is congruent to YZ. There's one thing I didn't do. I didn't do FZ is congruent to ZY or something like that. The reason I didn't do that is because I'm trying to follow the way that the question formulated the names of these segments. See, the question said ZF, right? The question said the ZF. Another proper name for this segment would be FZ, correct? It would be perfectly fine, but why mess with the way they named the segment, right? If they say ZF, use ZF and don't change the name of the segment, even though it would be just fine to do that. It just makes the question more confusing, right? So that's why when I was writing this, I was careful to write it in a way that they had formulated the question. So I wrote Sx over here because they wrote Sx over here. And I wrote xy over here because they wrote xy over here, and I wrote zf over here because they wrote zf over here, and I wrote yz over here because they wrote yz over here. So I was consistent in naming the segments the way they were doing it, just to make life easy for myself. Okay, now now look what we have here. This is from the definition. From definition, the midpoint that we know is Sx is equal to xy, and then I got zf is congruent to yz. So we got that. What we're trying to prove is zf is congruent to sx. Now we have this segment here, and we have this segment here, but we can't connect them together. This almost seems like transitive properties. A is equal to B and B is equal to C, then A is equal to C type thing, but not quite, because to have use the transitive property, you have to have something that's common between these two statements, and there's nothing common between these two statements here. There's no segment that's common that can act as a bridge. Now remember, we have transitive property of congruent segments. So for congruent segments, we have the reflexive property of congruent segments, symmetric property of congruent segment, and transitive property. If we had something common, we could just use the transitive property, but we don't have it, or not yet. Okay, that is, we have in that little diagram we have transitive property. Okay, for some, but here we can't use it just yet. Well, we're not done yet, right? Because we have more information that's given to us. Here's one piece of information that we have not yet used, so let's use that. All right, so we have this. So I've simply written down this given information: xy is congruent to yz, and that is simply from because of given information. Now, if you notice, well, how am I going to use that? Well, if you notice, in between these two statements, what I really want to go is ZF and SX. So I really like this, and I really like this. Those are the two statements that I want to, those segments that I want to preserve. I'm going to kind of get rid of these two and kind of make them equal. I almost feel like I could use transitive property. We're not quite there yet, right? But okay, let's see if we can manipulate this so we can use transitive property. All right, so I've written this down. XY is equal to YZ. Well, that's an equality statement, but I can change an equality statement into a congruent statement. So I can say XY is congruent, segment XY is congruent to segment YZ, like this. And this is because of definition of congruent segments. So that definition of congruent segments. Segments are congruent if they are equal lengths. Okay, now watch. Now that's pretty impressive now, because look, I have this statement, I have this statement, I have this statement, and they got lots of things in common. So I'm pretty sure somehow I could use a transitive property to get these two, because I have those two in here already. So I'm going to try to use transitive property between these two statements and that. So I have three statements, and I want to try to use transitive property to get this one to be congruent to this one from using the transitive property of congruent segments. So I'm using transitive property of congruent segments to somehow get to where I am. All right. Now, to use transitive property, if you recall, you have to have two statements that have something in common. Okay, let's look at this one. Now, these two have nothing in common, so forget that. So I have this one, and let's say this one here. All right. They have something in common, don't they? They have this one and that one is common, so that's good. I can use transitive property there. Okay, let's see if we can use transitive property there. So if I use the transitive property, I get with this one and this one. All right, so I'm going to get segment SX is going to be congruent to YZ, because between those two statements, between this one and this one, XY is congruent, so I can get rid of this, so SX is going to be congruent to YZ, right? So that is from transitive property of congruent segments. So I'm going to write that down. So that's transitive property of congruent segments. So that's transitive property of congruent segments. I got that. Well, what are we going to do now? Well, here's what we're going to do now. Okay, I have this statement here, and see, remember, I want to keep this, I want to keep this, right? I got this and this, so, but I really want this, right? But you can see, if I look at this statement and if I look at this statement, I have something remarkable. In those two statements, I have this segment and that segment common. That's pretty cool, because then I could use transitive property again to get ZF and SX to be congruent to each other, right? So let's do that. So I'm going to use transitive property again with this statement and this statement to get ZF to be congruent to SX like this. Ta-da! Here we go. So that's again transitive property of congruent segments, right? Because between these two, this one is common and that one is common, right? A equals B, B equals C, then A equals C. Now, again, if you notice over here, ZF is congruent to YZ, and ZF is congruent to SX. Now, if you remember last time, A equals B and B equals C, then A equals C. Sometimes it's not written A, B, B, C. Sometimes it's like this: A equals B, and C equals B, like this. Don't get that's the case over here, but don't get confused with that, because you can still use transitive property, because you can easily use symmetric property to get these to be the way you want. Anyway, so here we use transitive property two consecutive times to prove what we wanted to prove. Okay, now look, what did we do over here? All right, let's go over this proof one last time. Okay, so we give information, two midpoints. X is the midpoint and Z is the midpoint, and we got these congruent segments. It almost seems like we could use transitive property somehow, because there's a wealth of segments over here. But we couldn't use it over here just now. But we given a third piece of information, inequality, and we changed the equality into a congruent statement. Now we had three statements that had congruent, and somehow you better be able to guess transitive property out of them. So we used transitive property two times to get the statement that we really wanted to get. So here's another question. LK is congruent to NM. So LK, that's this little segment, is congruent to NM over here, that little segment. So that's the first bit of information that we're given. So LK is congruent to NM. Okay, very good. And then we're given KJ, KJ, that's this segment, I've written it, is congruent to MJ, like those two are congruent. All right. And then we are asked to prove that LJ, which is this over here, is congruent to NJ over here. That's what we asked to. That seems like a pretty easy proof. It looks like that one's the baby segment congruent, that baby segment, that one's congruent, that one. I should be able to do this, right? And, all right, so I'm gonna. Okay, so let's again. I don't want to go too fast. We're given that this baby segment is congruent to this segment over here, and then we're given that this segment is congruent to this segment over here. And then we're asked to prove that the big whole segments are congruent. Now, you don't get put off over here. They connected these two and I made a triangle out of it, and you might get confused. But they didn't even have to draw this line. It has nothing to do with line. You could just draw they could have given the question like this. See, to make tricky for little children, they kind of connected that. And, oh my God! Now we have a triangle. I've never seen a triangle in my life before. It's not. It's okay. We can handle this. All right. Let's see. Let's start our two-column proofs over here, and segments and statements. How many segments? That's why I do this actually, just to statements, not segments. Statement, STATMENTS, and here are the reasons. All right. So when in doubt, we write the given information. So the first thing is LK is congruent to NM, and then KJ, I'm just going to write them over here so it makes it easy for me visually. MJ, like this. Alright, so that's given information. Alright, so what can we do from there? Well, somehow I'm going to have to add stuff, and I'm going to have to use properties of addition property of segments somehow, I think. So Now, you might be tempted, if these are equal, just to add them. You can't just add them just yet, because these are all different numbers, different segments over here. So I'm going to actually change these congruencies to equalities. So from there I get LK is equal to NM, and I am told that KJ is equal to MJ. Alright, sorry, MJ. So now I've changed I've done nothing here except I just changed the congruencies. I just rewrote these, but without the congruencies. I wrote them as segment lengths. So that's definition of congruence. Okay. Now what do I do? Somehow I have to add these, right? So I have LK, that's this baby segment, equals to NM, that baby segment right here, right? So what I'm going to do here is this. I'm going to have to get some bigger segments. I'm going to take this particular statement. Watch this, okay? First, I'm just going to write this down. LK is equal to NM. I just rewrote this statement over here, okay? Then I'm going to do something pretty tricky. Maybe it's not as tricky as you think, okay? I'm just going to add, see, this is LK, right? I'm going to add this segment to get the bigger segment. But if I add something to one side, I have to add it to the other side. So LK plus KJ, okay? I added this. So, but I'm going to add it to both sides, right? Like that. So I took this segment right here. I saw that, and I added that segment to it, right? So then I got LK plus KJ and NM plus KJ. So I added KJ to both sides. So I took that statement, first rewrote it, and then I added that to both sides, because now I have big segments. So I generated big segments from this particular statement. Why can I do this? Why is it that I can do this? Well, I can do this because of, I hope you said it, because of addition property of equality. Addition property equality for real numbers. That's from the addition property of equality. If you want to say for real numbers, then you get like super extra credit points. Okay, so this is from addition property of equality. Addition property equality says if A is equal to B, then A plus C is equal to B plus C, like this. All right. So addition property of equality for real numbers. Oh, that's pretty cool. Now look, here I have LK and KJ. That's this over here. All right. Right. I have that. And then here I have NM and KJ. That's NM and KJ is over here, but I don't want KJ. I want this over here, right? Well, I can do that, right? Because I can just substitute MJ over place of KJ over here, can't I? Right? Because that's from substitution property of equality. So I can do this. Watch. So I'm just going to rewrite this side. So LK plus KJ is equal to NM plus MJ. So all I did was I substituted this in place of that. Okay. So now I have this and this on this side, this and this on this side, right? Okay, cool. Oh, there you go. Now this is because of substitution property. So this is from substitution property of equality for real numbers, because we're dealing with real numbers here, because that's why they're all equal signs. They're not congruent. So substitution property of equality. Now that's pretty cool. Now here it says LK is KJ, LK and KJ, and this side says NM and MJ. This side says NM and MJ. So now I have two baby segments, and two baby segments on each side, right? What does that say to me? Well, that tells me that this side is equal to LJ, doesn't it? Two baby segments give one big segment. And this side is NJ, isn't it? NM and MJ. Why can I say that? That's our favorite postulate. Segment addition postulate. Segment addition postulate says that two baby segments give one big segment, right? Basically, that's what it says in my language, at least. So if we follow, so using segment addition postulate, I can change this to this, and I can change that to that, like that. So I got that. Now I'm almost done. See LJ and NJ over here. Almost done, because then I have to say LJ is congruent to NJ, like this. All right. So, and this is from definition of congruent segments. Okay, now look. So we're done. Ta-da. So what do we do here? Let's review what we did. So we were given the two baby segments were congruent over here. This one was congruent to this one. Sorry, two baby segment. This one was congruent to this one. And then the two medium-sized segments were congruent. And from there we proved that the two bigger segments were congruent. Okay. So first we wrote down the game information. We converted the congruencies to equalities, because then you can use the properties of equalities. And then I cunningly added the same segment to both sides using addition property of equality. And then I used substitution property from KJ to MJ over here. And then I used two baby segments equals one big segments to give from, because of the segment addition postulate, and then converted the equality into congruence. Now you can see that although these proofs kind of started out simple, they can get reasonably more intricate, and this is just the beginning. And the way to master these is to, every time you do a proof like this, you should understand it, and you should try to do it again by yourself. And you do have to make such effort if you really want to master this and for this to be enjoyable for you. And if you put a little bit of effort in trying to do these proofs on your own until you feel comfortable with the logic. So the logic has to flow, because all we're doing is we're manipulating properties of real numbers: addition property, subtraction, multiplication, division property, reflexive, symmetric, transitive property, and substitution property, and etc. Last one, if you want to know, was the distributive property. We're using those properties in the postulate, segment addition postulate, and the properties of congruent segments to prove these things. And this will build up. And if you practice a little bit now, inshallah, it will be very, very helpful to you. Until next time, as-salatu was-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.